we're going to be talking all about functions. Function is just going to be kind of a fancy word for an equation. It's going to model a given situation. We're going to switch from looking at equations in the form y equals something to function notation, which we're going to look at later on in another objective. Before we move into that, though, we have to understand what domain and range are. Domain is going to be all of our possible input values. It's our independent variable. You may have heard that term from science class. Typically, our domain is going to be our x values, but because our equations are not always going to be in terms of x and y, there may be other variables, we say input or independent variable as opposed to saying x. Similarly, range is just going to be our output values or our dependent variable. Again, it's often the y, but because we're not always in terms of x and y, it won't always be y. The way it works is the dependent variable depends on the independent variable. So, for example, if we talk about your car getting a certain gas mileage or miles per gallon, the amount of gas you use depends on the miles driven. But now let's go ahead and look at some actual concrete examples where we're asked to list the domain and range. So here in example 1, I'm given a relationship. A relationship is just, or a relation is just a set of points, and I'm asked to find the domain and range. So in example 1, if I find my domain is my independent variable, and since y depends on x is going to be my independent variable, so I'm going to just use a bracket to show that I'm creating a set. It's not a very good bracket. Write that again. And in my bracket, I'm going to put all my x values. So I have -1, I have -4, I have a 2, and a 6. That's my domain. My range, on the other hand, is going to be all my y values. So doing the same thing and listing all my y values, I have a 3, I have a 0, I have a 2. I have another 3, but since I've already written 3, I do not need to write it twice if it overlaps. On the second example, I'm asked to do the same thing. I just have to find the domain and range. So finding my domain, again, my domain is my independent variable or my input, and I see that my domain, because y depends on x, is going to be my x values. So I'm going to go ahead and say -2, 0, 1, and 3. Again, notice I do not write the 1 twice. My range is just my y values. So I'm going to have a 4, a -3, got the 4 already, a 6, and a -4. So really all I'm doing is listing my x and my y values. On example 3, I'm asked to find the domain and range again, but now I'm given a graph. So when I look at example 3, I see that I start at an x value, if I'm talking about domain, of 0, and then I continue on and on and on. That arrow means it keeps going. So as I get bigger and bigger, I'm going to continue to use more and more x values. So based on this graph, it looks as though my domain is any x values greater than or equal to 0. If I look at my graph to find my range, my possible y values, it looks to me as if my y values start on the y-axis at 1 and continue to get bigger and bigger and bigger, implying that my range, or showing me that my range, is all y values greater than or equal to 1. If I did the same thing on example 4, in terms of my domain, what x values am I using? Well, I'm using all these x values back here. So it looks like I'm going anything less than 0 on this one. 0's included right here, but then it also looks like, according to this graph, it's anything bigger than 0. The way I'm going to write that is I'm going to say my domain can be anything. So I'm going to say it is all real numbers. For where we are at, every number we look at is going to be real. There is another set of numbers called imaginary numbers. However, we will not get into those for a while still. For right now, everything is real. My range, if I'm looking at my y values, well, it looks like all my y values are either at a y value of 1, because aren't the y value, or isn't the y value on this line always 1? And my y values are also bigger than 1. So once again, my range is going to be y values, and I'm sorry, that's not 1. This is a y value of -2. So I'm still apparently stuck on the third example. So at -2, all my y values are -2 on this line, and all my y values are greater than -2 on this line. So I'm going to say y values greater than or equal to -2. Finally, we also want to be able to find domain and range from a real-world situation. So looking at these last two examples, on example 5, Eric is selling cards for $20 a piece. We want to know what his possible domain and range is if he's planning to talk to at least 5 people. Well, first I have to figure out what's my input, what's my independent variable, and what's my output, what's my dependent variable. Well, if he's planning on talking to 5 people, doesn't the number of cards that he sells depend on the number of people he talks to? So I'm going to let my independent variable be the number of people Eric talks to. And remember, the independent variable is going to be my domain. So I'm going to go ahead and say my domain is going to be, he's planning to talk to at least 5. So I'm going to say my domain is greater than, and I'm going to go ahead and use x, greater than or equal to 5. So looking for my dependent variable is going to be the number of cards that he sells, because that is what depends on the number of people and depends on what the people say. So I'm going to go ahead and say that my range, well, since everyone could say no, I'm going to go ahead and say that my range, or my y, is going to be greater than or equal to 0. Hopefully, for Eric's sake, it's greater than 0. Hopefully he sells a lot, but he does have the potential of having everyone tell him no. Looking at the last example, I'm told the surface area A of a cube is the total outside area. It can be found by using this formula. And your teacher asks you to create a cube with a side of at least 2 inches. And if you remember from up here, my directions were to find the domain and range. So again, I need to know what is my independent variable. Well, doesn't area depend on my side length? So I'm going to go ahead and say my independent variable is my side length. And therefore, my dependent variable, as I just mentioned, my area depends on my side length. So I'm going to go ahead and say my dependent variable is my area. So finding my domain, well, since my teacher has asked me to make sure my side length is at least 2 inches, I'm going to go ahead and say S, because my formula uses S, not X. So I'm going to go ahead and say S is greater than or equal to 2. Well, so then what's my possible range? Well, if I start at 2, my area will be 6 times 2 squared, or 6 times 4, so 24. Well, if I use a side length that's bigger than 2, won't my area be bigger than 24? So I'm going to go ahead and say that my range, my A values, my possible A values, have to be greater than or equal to 24. And there's my domain and range. So we're either looking at a set of points, a graph, or a situation, but domain is always going to be the possible values for our independent variable, which is often x, and the range is always going to be the possible values for our dependent variable, which is often, but not always, y. Bring these with you to class. If you have any questions, we can talk about them then.